Hello everybody, this is Shiva, clinical SAS trainer from Great Online Training. So today I'm going to explain you how to create the demographic table in a simple steps. Most of the trainers they simply copy paste code in front of you and run it, and they will create and they develop the RTF in front of you. But in this session I'm going to tell you how to create the demographic table, each line and line. I'm going to write from the scratch programming onward, as well as I am going to explain what are the points need to check whenever you completed your output, as well as before releasing to the validation purpose, what are the points need to check in your output, so that you'll get a minimum comments from the QCR, and who are doing that validation person. So here I'm going to show you how to create the demographic table. Here the demographic table, in the demographic table, what are the requirement for the demographic table? Just we need a Adam dataset ADSL, and here this is the program I am going to write. Okay, so this is the mock shell. So here the mock shell is here, this is the mock shell. So the statistician will prepare the mock shell, how the shell looking like. Okay, so here subject demographics, they want to include safety population and age category, gender and race. Okay, so we need ADSL dataset. Already I placed this ADSL dataset. So while looking this mock shell, we are going to create the demographic table. So we can start our programming. So this is the RT demo 1. I'm giving the programming name as RT demo 1. So whenever you started any programming part, so what they know, every company, every client has a specific header. So you can copy header from your previous programming as well as any template. So here this is the template what actually our company is following. So the program name is RT demo 1. My name is Shiva, and I'm going to develop the table. So you can mention the table number. So here the table number is, so as per the mock shell, it is 14.1.3. So here you can write table 1.3. So what is the input data set? Adam.adsl. So we are going to use Adam.adsl data set to generate this table. Okay. So what is the output? So output is table 14.1.3. Okay. What are any standard macros if you are used? So you can mention the standard macros, otherwise you can give it as leave it as a blank only. So any modification history, whenever you release to your QC person, after that you will get any comments, so you can modify in that particular section. You need to mention what is the modification history you done for that particular section. You need to mention the date and time, what are the modification you done, just explain in a brief manner. Okay, so we can start our programming. So the first thing is go to the mark shell and look at once. So here the title itself showing subject demographics, and they want to include only the safety population patients. Okay, safety population. So here the Adam, we have an ADSL data set. So go and check with the ADSL. Here the ADSL data set. Okay, so here around 6 subjects are present. So go and view table column labels, all the labels are appeared. So this is the subject number 1 2 3 4 5 6 subjects data it is. So here as per the mock shell, they want to include only the safety population. Okay, go and check whether safety population flag is there. Here you can see safety population flag. So we have to take only the safety population flag, y equal to subject in this uh, table only. Okay, so ACFFL is the variable name. Okay, so we can start our programming so that you can understand. So first, whenever you write something, just give the comment, so that every other programmer also they can easily understand. Okay, extract the data, safety population data. Okay, so the main title itself showing they need to put only the safety population patients, right? So safety population data. So the comments and indentation is the more important for any program. So here data. So I'm giving demo underscore 1 data set. Set Which data set you are going to take? Adam.adsl. So which filter we are going to use? The SAFFL. Just now I copy, right? Safety population flag. Here this is the safety population flag equal to only the Y subject. Okay. So here I am taking only the Y subject. Just run. Okay, save it. So just run and run this one. So only 6 records are there. All 6 subjects are having the safety population. So here demo underscore 1. Okay, this table where you can delete. So you can delete and so here just run this one and here the demo underscore 1 data set was there. Okay, so all these observations, all these subjects have a safety population Y patient. Okay, now the next step is if you see the shell, they are asking treatment A and treatment B as well as overall. So we have a two treatment. So if we go and check with the demo underscore 1 also, so the TRT treatment related information here, actual treatment is. So here the two types of treatments are allotted to all these 6 subjects. 100 mg TG3304 is the one treatment and placebo is the another treatment. Some of the subjects they may receive 3 subjects receive placebo treatment and 3 subjects receive the active treatment. So we can we have a two treatment, but actually in the mock shell they are asking treatment A, treatment B as well as overall. How can we get this overall treatment? By writing the simple step we can get like, so you can also write the comment section adding the overall treatments. So how to add the overall treatment? So data demo underscore 2 set demo underscore 1. So just put the output statement. So all the records are getting output. Now we are going to add the TRT01 equal to all treatment. Okay. So that what happened, then again you put output statement run. Each and every records comes to the overall also. So just I can run it. So demo underscore 2. If you see all the 6 record going at a double 612 records and the TRT01 a variable here you can see each subject has an actual treatment and that subject will also considering in the all treatment. So placebo also considering all and each and every subject having the all treatment. So whenever you write the proc freak or proc summary proc means statement, that time you will get the this treatment first treatment count, placebo treatment count as well as all treatment counts also. Okay, so here the next step is, so for the simplification purpose I just give some order to the treatments. Okay, so just giving the comment assigning the order to treatments. Okay, so how can we assign this one? So data demo underscore 3 set demo underscore 2. So for example, if index of this particular TRT01A variable containing the, so what are the information containing in the TRT01A? So here this one. Okay, so this treatment containing this treatment greater than 0, then just giving the, so variable I am giving TRT equal to A, so and I'm giving the order equal to 1. Okay, so for simplification purpose, this is a first treatment and this is a treatment and I'm giving the order 1. So the same way placebo I am giving the second treatment. So here the placebo is I'm giving the treatment as B. Okay, treatment as B and I'm giving the order equal to 2. In the same way, I'm going to give the order 3 for overall. Okay. So here the all treatment. So I'm giving the order same as well all. So I'm giving the order 3. What happen, whenever you are going to transpose anything or anywhere, so if you are giving the same order, so the same order it will go in populate in the output data set. That's why I'm giving the A treatment 1, B treatment 2, all treatment 3. The same the mock shell also, first treatment, second treatment and all. So we are giving A treatment for this, B treatment for this one, all treatment for overall. Okay. And what are the variables required for this table? Just keep those variables only, so that you can easily understand the data set whenever you want to check the data set. So few variables present in the data set, it is easily to review the data set also. Okay. Subject is the main important, use subject id. And now we created the trt and ord variable. So what are the variables needed for this one? Age, gender as well as race. So for the age, we have a variable here, the age variable is there, so you can copy the age. For the gender, we have a sex variable is there, so you can take it from the sex variable data set. And one more thing, age, gender as well as race. So you can find the race also here, the race variable also present. So keep these variables. These variables are much enough to produce this table. Okay. So here I'm running the demo underscore 3. So here the demo underscore 3 data. So only this information is much enough to produce the table. Okay. So subject number, age, sex, race and TRT as well as ORD. So here the TRT, there is a truncation problem happen. I think if we are not giving any length to treatment, so what the first length we are giving, automatically it is also taking the same length. So that's why I'm giving the length treatment of length statement for the TRT, just giving the around 10 is fine. Now if you run this one and check, so we missed the semicolon. If you run this one, and here you can see demo underscore 3. Here A treatment, all treatment, B treatment, all treatment. Each and every subject belongs to the all as well as what the treatment he has taken during the clinical trial that was assigned. Okay. So now just save the data set. And now the next step is just sort the data set. Okay. Proc sort by each and every subject wise, and we are giving the treatment order, right? So ORD wise. So if you run this sort statement, so automatically demo underscore 3. So each and every subject and particular all treatment. Okay. So without giving any data statement in the proc sort, automatically it will take from the previous data set. Okay. So the next and most important thing is look into the table. So we are considering the safety population and we filter the data and we have populated. Now, if you see here, they mention something like big N counts. So we can call it as this is big N. This is the most important. What is this big N? Nothing but N equal to N equal to mention, right? So how many overall subjects are assigned to this particular treatment in this population? In this population, how many subjects are assigned to this treatment and overall treatment they want to show in this one. So we are not directly creating and pasting in this one, so we have to create the macro variable at the time of proc report section. We can resolve that macro variable in the proc report section. Initially we have to create this Kaplan count. Okay, so here the percentage counts are there. So here this xx divided by Kaplan into 100 will give you the percentage. So for this, first, we need to create this Kaplan. Any table in the clinical trial, if the table mentioned the Kaplan count or big N count, we need to derive and we have to create those as a macro variables. So here I'm creating the macro variable by using Proc SQL method. So here big N count derivation. Okay. So here the interview people also they will ask you what is the begin and what is the how to derive that one. Okay, generally I use proc SQL method to create the begin count. This is the easy method to create the begin method. Okay, proc SQL, now print and select. So you can count the distinct each and every unique subject ID and giving the into class method. So we have a three treatment. So N1 to N3 three treatments from demo underscore 3 data set. Okay. So demo underscore 3 just group by. So we have already created the order variable, right? So you can mention the ORD and ordered by ORD. So you want to check whether the counts, getting correct or not. So you can mention N1 count, N2 count, and N3 count. Okay. So here just see in the log. So here you can see 336, nothing but three subjects belong to the first treatment. That is first treatment, nothing but A treatment. A treatment, nothing but TG3304 count is three subjects and B treatment count as three subjects and overall six subjects. Here you can see 336. N3 nothing but overall how many subjects. So this N capital N count, big N count we just created as a macro variable. Later we can use this macro variable for further derivations. Okay. So coming to the body part of your first variable. Here they mention age variable. They want to give the summary statistics. Summary statistics nothing but n mean, median, and standard deviation, minimum, maximum. This age variable is a continuous variable and the gender race is a categorical variable. You already know when it is a group by something, gender has a limited male or female, that is group by. So what are the variables we can created as a groups, so we can call it as categorical. So individual entities like age is a individual entity and that is different to subject. Okay, so whenever you are not getting into a group by those variables, we can call it as continuous variable. Continuous numeric variable, we use some procedure to get the summary statistics. You already know the summary statistic n mean, median, how to get by using different procedure. Proc means, proc summary, proc univariate, any of the procedure you can use to get this summary statistics. So here now I'm going to use the proc summary method. Okay, getting summary statistics of age variable. Okay, so here I'm using the proc summary method. Okay, yeah, data equal to which data set, demo underscore 3 NV method. Okay, only what mentioned in the class variable, only that way only we are getting the variable. See, unnecessary other related combinations we no need, so that's why I'm mentioning NV. So class equal to treatment. What is the variable name? So we are going to do the summary statistics and age variable. And how to get the output out equal to, I'm giving some dm underscore 2. So what are the statistics you need? N equal to underscore n. So mean equal to underscore mean, median equal to underscore median, and standard deviation equal to underscore standard deviation, and minimum equal to underscore minimum, and maximum equal to underscore max. Okay, so just run this one. So only these statistics you need populate in the table, right? So you can go and check n, mean, median, standard deviation, minimum and maximum. That's why I just mentioning only n, mean, median, standard deviation, minimum and maximum. If you run this one and dm underscore 2, so here you can see, go and go to the labels. So this treatment, A treatment, all treatment and B treatment. So this is the n, this is the mean, this is the median, this is standard deviation, minimum and maximum. Okay. So now we don't want to put as it is, because here you can see they mentioned some decimal alignment, etc. things. So here if you carefully see, they mentioned they want to show n as xx, means without decimal, mean they want to put only one decimal. If you say xx dot x, only up to one decimal they want to show. And in case of standard deviation, they want to show up to two decimal, xx dot xx, and minimum, median, minimum and maximum value they don't want to show as a decimal value. So in the mark shell showing the decimal alignment. So here if you see your demo dm underscore 2, there is no decimal and etc things, but we have to represent as per the mark shell. For that purpose, so we do the decimal alignment. So decimal programming. Okay. So how to get the decimals and etc things? Data dm underscore 3 set dm underscore 2. So the first variable is n equal to, just I am compressing, convert into the numeric to character. What is this one? Underscore n. Just I am giving the without decimal, only 3 dot. Okay. So in case of mean, just copy this thing. So the mean, they are asking us to produce the mean into one decimal, xx dot x. So here the mean, so one decimal means 4.1. Okay. In the same case, median also, so here the median, same, one decimal. In case of standard deviation, two decimals, right? So as per the shell, it is a two decimals. So if you go and see the standard deviation, they mentioned xx dot xx, two decimals. So here you can give the two decimals, 5.2. So here the variable is standard. So no decimal for minimum and maximum. So you can copy this one and paste it here. Here you can give minimum and next thing is maximum. So just convert as per your mark shells. Okay. Now you can run. So here dm underscore 3. Here these are the variables defaultly we get from the using proc summary method. Now we converted them into the as per our convenient. You can see mean 48.3 and median, standard deviation, minimum and maximum. So here up to two decimals we created. Now, but as per the shell, everything statistics should be in a one column. So for that purpose, so what is the comment? Treatments should be treatments okay, convert to column wise. Okay. So why we have converted this one? You see here, treatments are in a one column, but as per the shell, the treatments are in three columns, right? So we need to transpose this, as well as we need to transpose this into the one column wise. So how to do the conversion? By using the proc transpose method. Okay, proc transpose data equal to dm underscore 3, out equal to dm underscore 4. So what is the id variable? We need to do the rows to column treatment, and what are the variables? N, mean, median, standard deviation, minimum and maximum. Okay, so if you see after the dm underscore 4, so here you can see all these variables get into the one column, A treatment, B treatment, as well as all column. Here you can see standard deviation is 2 decimal, mean and medium is 1 decimal. Okay, minimum, maximum and n, we don't have any decimals. So up to now is fine. And if you look at the shell, so they mentioned category and statistics in the same order. Okay, so if you are directly using the variable what we have, it will go in the alphabetical order wise. So for that purpose, we need to give each and everything as a one unique number, so that we use that same number in the proc report section to display as it is. As well as we need to add this category also. So adding category, and ordering of order of the starts. Okay, so for that purpose, data, I am giving dm underscore 5, set dm underscore 4. Okay, so the first variable is category variable. So what the category variable containing? So age in years. Okay, age year. So we can give as a age years. And the next, this is all these are statistics, right? So n, mean, median, everything as statistics variable. So we can give as stat start variable. We can give underscore name underscore. We already having the demo underscore 4 dataset underscore name underscore all the starts, right? So I'm giving underscore name, the temporary variable, to this permanent variable. So now giving some length to this category and start. So length of category and start, you can give like 100. So no truncation problems will happen in the future. Okay. So the next, we need to convert everything as per our shell. So if start variable equal to, so it is, if it is a n, okay, then do. How we are going to represent in the shell? Just go and check with the shell. So here also they ask n only. So we can directly give the n, and giving some order to this one, so that OD equal to 1 and n. Okay. So the same thing if it is a mean. So if you are directly using underscore name underscore as a sorting variable, automatically it goes to the alphabetical order wise. But we have to represent this order, same order in the output mentioned in the mark shell, what the order they mentioned, the as it is order we are going to put. Here the mean they mentioned, but here the prop case mean they represent. So that's why we converted that mean into mean and give the order 2. Okay. So the third thing is if it is a median. So what the mentioned, so here the prop case median, so it is a median and giving the order 3. So the same way, if it is a standard deviation, so what they mentioned, the standard deviation SD, so order equal to 4. So what the order mentioning in the shell, the same order you can give. So the minimum, So giving the minimum, here the minimum, and the ROD equal to 5. And the last one is maximum. So if it is a max, so that the same thing maximum what the shell they maintain. So giving the maximum and give the order 6. Okay. So run it. Okay. So the DM underscore 5 data set, you can get category variable and statistics variable and the statistics order variable and A, B as well as here A is character. Okay. A, B and all treatment. Okay. So you can drop this variable. So you can drop underscore name underscore variable. So up to now, we just derived the summary statistics of age variable. Okay, DM underscore the start here category variable, statistics variable. You can see the mock shell category variable, statistics variable, A treatment, B treatment, and all treatment. So here category, statistics, A treatment, B treatment, all treatment counts. Now we are going up to now this was done. Age statistics was done. Okay. What about this gender and race? So here we are counting in mean median statistics, but this is a categorical data. We have to put this into the counts and percentages. So we look one by one. So up to now end the age starts. Okay. The next thing is start the gender stats. Okay. So what is the method we have to use to get the summary statistics as proc means or proc summary, proc invariant. In case of counts and percentages for categorical era, just use the proc frequency method to get all these counts and percentages. Proc freq data equal to, so which data set we are using for this one. So the same variable you can use. Okay. So give the no print option and the tables treatment versus the variable is sex, right? So you can give the out data set name as gender. You can drop the percentage here because what the percentage we are getting by default, we are not going to consider that percentage. So we do the manual percentage calculations. Okay. So in any table, what the proc frequency we giving the percentage, we no need to consider that one. We do the manual percentage calculation. So here the gender data set, you will get the treatment wise all treatment, A treatment and B treatment. Each treatment wise how many males or females are there. Here B treatment one female, two females and one male. In case of all A treatment male are three subjects. All treatment two out of six subject, two are female, four are male. So we are getting the counts and data gender set the same gender. Okay, I'm not going to give the changing the any data set name. So here also we have a category variable. So category equal to gender. So for the alignment purpose, so use the same category. So cat variable equal to gender. Okay, and giving the same length what we are giving here because finally we are going to set these two data set. For that purpose, that time we will get the multiple length statement for if we are giving different length to each and every variable. Okay, so same length you can use and here the start variable If for example sex equal to male, then do the start variable equal to male. Why I'm showing this m as male? Here you can see, as per the shell, if it is m, we have to represent it as a male. Okay, so giving the order also one. Otherwise, female goes to the first and male goes to the second in case if you sort the same variable. Okay, so here if it is a female, so giving the female. Okay, as per the shell, if it is a female in a prop case, so giving the order 2. Just run it. Okay, let us see gender equal to, now the category variable and statistics and the order and the counts we are getting 3 2 4 1. Okay, so sort the data set, proc sort by category wise, OD wise. And after that one, we need to transpose the data, because here also treatments are in one column. We need to transpose in a column wise. Okay, so transpose data equal to gender, out equal to, can give gender underscore. Okay, so what is the by variable? So category variable and the OD and start. Okay, here you can see category variable, statistics variable. So statistics we created a one numeric version variable, OD and start. Here the OD and start. So what is the ID variable here? Treatment. And the what is the var variable here? Count variable. Upon doing this one, just here you can see gender underscore, you will get all these things. So these are the temporary variables created. So here the gender and the male and female, and A treatment 3 subjects, and B treatment 1 subject and 2 subject, all treatment 4 subject and 3 subject. Here the dot nothing but 0 subjects. Okay, so we are getting the shape of gender. Okay, now we are going to start the race category also. Do the same thing for the race. Okay, so because if you see the shell, they mentioned gender as well as race also. Okay, so how to do the race? Use the same procedure. Instead of sex variable, we are going to change the, in case here you can write it as a race, and here you can give as a race. Okay, so just run and check. So here Asian white. Okay, and later just copy this code up to this, paste it here, race data set, and here race data set. Here it is a race, so here race, and here also race. What is the race categories containing? One is Asian, another one is white. So what is the order? Asian and other, or Asian and white? So Asian, so Asian, and next one is white. So you can also mention the white. Okay, once we done, the same transpose method also you can use here. Race, I'm giving as a race underscore. Okay, so now if you run this one, so now the race underscore, how much Asian count? A treatment and B treatment and here the count and B count and all count for race. And sex underscore data set, you can get all the gender underscore data set, you can get all the counts for this sex category. Now we are going to set the race and set the race and sex counts. Okay, data. So final setting of this gender underscore, yeah, this gender underscore and this race underscore. Okay, just see. See here in the final data set. So here this is the gender and this is the race and this is the status male and female and this is the Asian and white and this is the A treatment count, this is a B treatment count, this is the all treatment count. So we are having only the counts, but as per the shell they want to display as the counts as well as percentages within the bracket. So up to 1 decimal. Okay, this is what they are asking. Only the count they are not asking, including the percentage. So how we are going to count, get the percentage? This count we are getting now, this count, right? This count divided by this capital N count into 100 will give you this count. Okay, so how to get that one, I'll show you. So for example, if A equal to dot, then if anything was dot, then you can give as a, so this is a drag A equal to, just creating the new variable, so giving the 0 count when there is a missing. For example, here we are getting a missing, right? So missing nothing but 0 count. Whenever there is a missing, so directly giving the 0 here. So here if A is missing, I'm creating the new variable drag A is missing. Else if A equal to ampersand n1, we created n1, n2, n3 macro variables here, right? This is the total number of subjects of treatment A, this is the total number of subject treatment B, this is the overall subject. For example, here this treatment, okay, so here this treatment, for example, 10 subjects are male, total 10 subjects are there. 10 divided by 10 into 100 will give you the obviously 100%. So for that purpose, I just written a code. This is the treatment. So number of small n equal to the this big N. Directly we are going to give the 100%. Okay. Then drag A equal to put of that particular A, comma best dot concatenated with directly the 100%. Okay, no need to calculate the 100% cases also. Directly if the small n equal to the capital N, directly you can give the 100%. Okay, just giving the length of this drag A, so you can give 100. Okay, so in the final you can see we calculated drag A, right? So why it is not? So if it is a similar, we just giving 100%. Otherwise if drag A equal to put of the particular A, comma best dot, otherwise 3 dot is fine. 3 dot. So here also you can mention 3 dot concatenated with. So how the percentages they are asking? First open bracket, okay, and again how to calculate the percentage? Small n divided by capital N of the particular treatment into 100 up to how many decimals? Up to 1 decimal. So 4.1, closing the brackets. Okay, now you can see. So here you can see Drag A, it is a, if it is a 100%, directly giving the 100. Otherwise, 2 into the percentage, open bracket up to 1 decimal. Okay. So 0 also you can give space, so that the 0 also completely aligned to here. Okay. So this is the A treatment. The same way we are going to do for B treatment also. We have 3 treatments, right? A, B and overall. So just copy this thing and paste it here. And if it is a B treatment, so drag B. If it is a B equal to, so what is the B? Total number of subject N2, right? Here drag B. So here the B treatment, and here the B treatment, and here the B, and here the B, and here the N2. Okay, here also you can mention drag A and drag B. Okay, the same way you can do the all treatment also. So here they mentioned all, right? So here all equal to is missing. So you can give as, so all P. So all P also you can mention here length. So if it is a all equal to N3 macro variable, so all P you can give as all. So here also all P, so put as all. The same way all divided by N3 macro variable. So each treatment we derived, the Kaplan counts there, right? So here in the final data set, if you see, the drag A counts with percentages, drag B also counts with percentages, all P also counts with percentages. This is, sex and this one, right? Now we are going to add the age as well as, so set the age starts and gender and race starts. Okay. So data equal to final underscore final. Okay. Set. So what is the final data set for here? DM underscore 5. What is here? Final. Just run. So here has to be within, okay. You can drop here, no need that A, B, C, right? So drop A, B as well as all. So now the final underscore final data set. Here you can see, you can drop this one, no need this one. So this is a facts category statistics under, and this also temporary variable, so you can drop. So this is the shell. If you see the shell as it is, I am getting this one: category statistics, treatment A, treatment B and overall. So here category statistics and this order of the statistics, and A treatment, B treatment and this all P. So here drag A, drag B, all P, we don't get this value. So for that purpose, so here dm underscore fun all AB. Okay. So here also we do the same thing here. So here drag A, drag B, drag C, right? So drag A equal to put off the A treatment into 3 dot. So drag B also put off B treatment comma 3 dot, and all P treatment equal to put off all treatment in 3 dot. Okay. So what are the same variables there in the data set? I am giving the same here also. So multiple length statement. So what the length we are giving here, the same length I am going to give there also. Now final underscore final data set. Here you can see drag A count, drag B count, and all P counts. Okay, you can drop here. This was a hide. Now we are going to write this final underscore final data set into the proc report. So we have two standard macros here. So that will take care about the titles, footnotes, as well as the RTF alignment. No need to apply anything. Just you can write the proc report section. Okay. So the macro is mtitle t. So here you can mention the which program you are using. Program ID equal to. So here we are using RT demo 1. So just this simple mention. So it automatically pick the titles and footnotes from other Excel sheet. Already they mentioned all the titles and footnotes respective program. So this macro will take it from all the titles and footnotes from there if you mention the program ID. Okay. So every company do the same thing. No need to write the ODS RTF file equal to the particular path and etc. This standard macros will take care everything. Just you can focus on your proc report. ODS escape char equal to cap symbol. So what happened this one? So whenever we have a special character, we are going to escape those one. So the next thing is write the proc report section. Proc report data equal to, so which is the final data set, final underscore final. So no windows option. We are not going to put all these things into the output window. So no window is controlling, that was not printed in this output window. And for headline head skip. So here they are asking headlines, right? So headline, this is the headline purpose, and there is a space before this one. So head skip. So head skip and split equal to, I just mentioned one pipe symbol. So I'll tell you what is the split option, and any missing data also we are considering. So mentioning the missing. So style equal to output width equal to how much? 100%. Total output width equal to 100%. And each and every variable we have to give the spacing equal to, I am giving the 1. If any long string are there, so automatically it will go into the next line. So that purpose I am mentioning the wrap statement. And how the header should be, header of the overall table should be the justification equal to left alignment. Okay, so you can mention the CR left. So as per the shell, so it is everything in a central alignment. You can put it as in a central alignment as well. Okay, so next you can write the column statement. What are the variables you want to show? So first variable is category statistics. So first variable is category, next variable statistics. So statistics, before statistics mention, start mention, we have created one OD variable to produce this one, right? OD and this one. So whenever you created any numeric variable for particular order, so mention the numeric variable first, and later you mentioned that category. So after this one, we have a treatment. Under that there is a line, and under the true treatment was populated. So for this line purpose, so you can mention S equal to, so how the border equal to, border bottom ULO or color equal to black, and the border, the bottom, the width of this one, just give the 2. So close this one. And what is the label here? They mention treatment. So here you can mention the treatment. And after that one, what are the variables under the treatment? A and B. So here you can mention drug A and drug B. So after that one, all P. Okay. So here within this line, there is a drug A, drug B we want to display, and out of the line, we need to show the all treatments counts. Okay. So define each and every variable in a specified manner. Define the first variable is category variable. Okay. So give the group, and what is the label of the group, the category variable here as per the shell category. So you can give the style, how the column should be. So the justification equal to left alignment, and give the some specific cell width to each and every variable. Here I am giving 10% to this variable. After, once we get that output, you can adjust the cell width. Okay. And this is the column, and how to define the header. So header also same thing. So the next variable is OD variable. No need to print this one because they are not asking any sequence. They just want to display the statistics. Okay. So OD order, we are not going to print this one. So no print. So the next variable is start variable. So you can copy the same thing here to here. So the statistics variable. So what is the label as per the cell for the statistics? So statistics, giving the same cell width up to now. Later we can decide whether it was truncated or not. And the next, the treatment drug A and drug B and all P. So here drug A. So what is the drug A here? Yeah, this is the drug A, and as well as they want to show here under there is a Kaplan count. So we already derived the macro variable. So here you can give the pipe symbol. So automatically it will goes to the next one. So here we mentioned the split equal to this one, right? Pipe symbol. So if you are using the split symbol here, so automatically it will go to the next line. If you are giving the split equal to star symbol, so you can want to split that sentence into two parts. So you can mention the split character here. Okay. So after that one, n equal to ampersand n1. Okay. This is a drug A, and next drug B. So what is the drug B? Placebo. So here you can mention N2, and the next all P. So what they mentioned as per the shell, it is overall they mentioned. So here you can mention overall N3. And we need to give the each and every section we have in a space, right? Gender before one space, race before one space. So each category we are going to give some space. So you can give compute before each and every category. You can give the line space and come. Okay. So run this one. Close all the ODS which are open. And give the one more macro, like the page nation number, page of macro. Once the given, just run the code. and you can see this output was generated. So here the category and the statistics and the values. So here there is a truncation problem happen. So 48 and 35. So we need to check how it was, why it was truncated. So in the final underscore final data, so here itself getting truncated the value. So go and check in the data. So here instead of this dm underscore 4 data, so try with the base dot. So this was happen in a real-time scenario. What happened when there is was not truncated? Just go and check in the data set itself. So base dot is not supported. So you can give the 1234.1. So you can give the 4.1 format also, not a problem. It's fine. So now save and close this output. So while seeing only I can find 48 point something is missing here. Okay. So in this way you can check your output also. So now just run this everything. So now here the exactly populated 48.3, 48.0, 3.51, etc. Complete decimals were populated. But here there is a one line missing before this one, right? So as per the shells, they mentioned two lines, above line and below line. So we can drop a line here also by using the compute statement. Compute before underscore page underscore before the page. You can give the line. So how the line is? For the line we are use this one, so you can use the same line here also. Okay, so here the line was populated. Okay, so the category, statistics, and everything as per the shell what they mentioned in the body. So they mentioned like xxx. Now we are populated all the values as per the data. So here also they mentioned n equal to xx, but as per the here n equal to 3, n equal to 3, overall number 6 subject, and these are the counts as well as percentage. If there is no count, we are generating 0%. If there is a 100%, we are going to populate it as 100%. So other than we are giving the up to 1 decimal percentage. So we need to check whether before this one how to check this one. First, you need to check whether the titles and footnotes are populated as per the shell. Second, you need to check whether any small in count, these we can consider small in counts is greater than the capital in count or not. Every percentages below 100% or not, we need to check. Above 100% it is not in a right one, that not make a sense. And the page numbers are populated and any protocol numbers are populated right or not. When we are creating, and what type of footnote they mentioned in the mock shell, as it is present or not, where there is a space is present or not, what the order they mentioned the same as order is present is or not, the Kaplan counts is present or not. We need to check in this way and releasing this output to your QC person. Okay, so here this is a way to create this much of program is required to generate the demographic table. Okay, so if they mention like any statistics, if you know how to create this one and this one, so you can generate 90% of the outputs in any clinical study, because most of the clinical studies they have either summary statistics or there are counts and percentages counts. If you know how to do the counts and percentages, from this code you can proc freak, you can code and you can write and you can get the numbers. If they want summary statistic, you can write the proc means or proc summary, get this all this summary statistics. Okay, Thank you everybody for watching this video. Thank you. Bye.